Alright, up to now we've been talking about eigenvectors and eigenvalues for matrices, for n by n matrices, and now we'll define them for just a linear operator on a vector space. So this is the equivalent of moving from Rn to just general vector space. So let's say I have a linear operator on some general vector space V. A vector W in V is an eigenvector for the operator T if, well, we want the same thing as for matrices. For matrices, we multiplied the vector by A and got a multiple for it. The equivalent thing here is to apply T, is to apply T to W and get a multiple of W. So if T of W equals lambda W for some lambda in R. Alright, obviously we're going to call that lambda an eigenvalue. Alright, so we have eigenvectors for linear transformation, linear operators, and we get eigenvalues as well. Let me do one example. Alright, so let's say I have V is going to be the vector space of functions with all derivatives being continuous. So be the space so this is a subspace of f minus infinity to plus infinity. I'm going to define a linear operator on it. Just the derivative, so it's going to send a function f to the derivative with regards to its variable x. I want to find the eigenvalues of this. In fact, what I'm going to prove is strange for what we've seen so far. I want to prove that every single real number is an eigenvalue. Alright, so this is strange. I don't have any matrices, I don't have a characteristic polynomial, I don't have anything like that. So in this case, I'll have to go back to the definition. To prove that something is an eigenvalue, I need to find a corresponding eigenvector. Since I don't have a matrix, we don't have a null space, we don't have anything, any tricks like that here, I'm going to just guess. So what do we need? We need a function f of x a nice function, infinitely differentiable, so that when I differentiate it, I get lambda times f. That's what it would mean for it to be an eigenvector. Do we know such a function? Yes, we can take the exponential. So I'm going to take f of x to be e lambda x. Then if I take f prime, I get e lambda x times lambda, that's lambda times f of x. And so that means this is an eigenvector with eigenvalue lambda. So that means every single real number is an eigenvalue for this, which is only possible because this vector space is infinitely dimensional.